Hello and Assalamu alaikum. Welcome to Mathematics with Shahab Yaqub. So now let's solve this particular past paper, which is paper 6 probability and starts 2. It's from October, November 2025 and the variant is 65. So let's get started. So now over here, let's look at the first question. The first question says, a student notes that the length t minutes of certain lectures, the result for a random sample of 80 lectures is summarized as follows. We are given the value of n, sigma t square, t stands for the time. So now the very first thing, calculate a 96% confidence interval for the population mean length of lectures. Now, does it say it follows normal distribution? It does not say so. So now, very first thing is that we should write over here that since sample size is large, what is the definition of large sample size? N is greater than or equal to 30. Therefore, CLT applies. It now becomes an approximately normal distribution. Now, where does it say we are using normal distribution? We are using normal distribution over here. We need the z value. So now this is 96% confidence interval. 4% is divided equally. We read the z value for 96 plus 2, which is 98%. So that is the z value. As usual, we find t bar, which is sigma t over n. We find the sample variance, which is sigma t square over n minus t bar square. That is sigma t bar square, sigma t square. And then this is t bar from here. And I did not evaluate it as yet. I simply wrote it down over here. So let's look over here. I took this whole thing and I wrote it down over here. That is the sample variance. And then I multiplied it with n over n minus 1. And then I get this answer. This is the unrounded answer, because if the final answer is given to 3SF, you should use the unrounded value. So now the formula for confidence interval, that is t bar plus minus z sigma over root n. That is t bar, that is z, that is sigma. This is actually sigma square. So keep in mind, this is sigma square. So therefore, we write sigma square and then the under root divided by 80. And these are the two answers given correct to three significant figures. You have to take care of accuracy a lot. Now it says this method used in part A is valid because the sample size was large. Explain why the method would not be valid if the sample size were small. So now, first of all, it does not follow normal distribution. So only if it follows this thing, that sample size is large, then CLT will apply. Otherwise, it won't apply. We cannot use the z value because it's not normal. Question number 2. It says a researcher is investigating whether the proportion of families who do not own a car in this town is different. Keep focus on the word different from the proportion of the population in the whole country, which is 10.1%. He takes a large random sample of families in his town and find the proportion of families that do not own a car. So let me also underline this thing. He takes a large random sample. So that is why again over here, we can use the z value as they have used it. So now this is like a partial question. Like most of the information is given. You don't have to do the calculation. First it says explain why a two-tailed test is appropriate, because the word used is different. We are not sure whether it has increased. We are not sure whether it has decreased. So therefore two-tailed is the best option. State suitable null and alternative hypothesis. That's a percentage. That's a probability. So I wrote P over here. And P does not equal to this. Now, since it's a large sample, therefore normal approximation applied, and that is why they gave a z value. The researcher calculates the value of the test statistic z and find that z is this much. He carries out the test at the 5% significance level. It's a two-tailed test. 5% is divided equally, 2.5% at each end, negative 1.96, positive 1.96 state the conclusion of the test. Now the rule is, does the z value lie in the critical region? First of all, z value is positive, so focus on the upper tail. If the z value were to be negative, we would have focused on the lower tail. The z value does not lie in the critical region. Do not reject h naught, except h naught. Technically, we have to write this. insufficient evidence. And one more thing, this is for your own use, just to reach this conclusion. This is what the examiner will check. There is insufficient evidence at the 5% significance level to prove that the proportion is different. So we don't have sufficient evidence or significant evidence for this thing. Always make a habit of mentioning the significance level, because at the significance level, this is what you are concluding. Question number 3. Now it says a certain website receives an average of mu hits per hour. In the past, the value of mu was 14.4. After making some improvements, the owner of the website wishes to test whether the value of mu has increased. Now it's a clear-cut increase. It's an upper tail test. If they ask for a test, he chooses a 10-minute period. So 60 minutes, mu is 14.4, 10 minutes. This is lambda. So divide by 6, divided by 6, that is 2.4. He chooses a 10-minute period, finds that there were 6 hits. So this is the sample value that is by default inclusive. You may assume that the number of hits the website receives in any given period follows a Poisson distribution. Carry out the test at the 2.5% significance level. And by the way, I'm not sure whether I've mentioned it or not. This is October-November 2025, variance 65. It was a nice paper. So now carry out the test at the 2.5% significance level. Now, first of all, X follows a Poisson distribution like this. And secondly, lambda is greater. That's the alternative hypothesis. Sample value is 6. So therefore, we calculate probability in the upper tail direction. 1 minus probability X is less than or equal to 5. Now from the calculation perspective. So now from calculation perspective, what do you need to show to the examiner to gain full marks? Because that is very important. So now you should evaluate this thing like this. And this is 1, 2, this is 3, this is 4, and this is 5, like this. And you have all these values lesser than or equal to 5. So yes, I forgot to write one thing over here, which I included in the calculation. That is 2.4 power 5 over 5 factorial. And yes, this value corresponds to this. So now show all of this. Now plug this in the calculator, multiply with e raised to power of negative 2.4 and then 1 minus whatever this value is after multiplication. Then you write down this answer. So you have to show all the working. And then I converted it to percentage. Why did I convert it into percentage? So that we can compare this percentage with the significance level. If it's lesser, reject H0. If it's not lesser, do not reject H0. You have to accept H0. Again, from the examiner's perspective, this is what you have to tell to the examiner. So there is insufficient evidence at the 2.5% significance level that mu has increased. So there is no increase of this mu at this particular significance level. Now the next part, they ask it a lot of time. Explain whether it is possible that a type 1 error or type 2 error or both may have been occurred. Now both can never occur. Because type 1 error, this is related with rejection region. Type 2 error, this is related with acceptance region. H0 is not rejected. In other words, H0 is accepted. So we are talking about acceptance region. So therefore, type 2 error could occur, type 1 error could not. That's a simple rule that you have to follow. Question number 4. Now it says a sports fan produces a magazine each month. On average, this is part A, on average 1 in 540 characters in the magazine is incorrect. Part 1, use an approximating distribution. What it means is that use an approximation. Find the probability that in a magazine containing 2430 characters, there are at least 4 incorrect. So now you have to realize that the original question, this is about binomial. That is the number of trials. That is the probability of success. We calculate expectation of X. That comes out to be 4.5. Now, since they have asked for the justification, that is why I did the justification at the end. Otherwise, I would have done it at the top. Since n is greater than 50, NP is lesser than 5, therefore X follows a Poisson distribution with NP. That is the justification, the criteria that you have to fulfill. Now it further says that now X follows a Poisson distribution. Now there is no continuity correction. We are interested in greater than or equal to 4, lesser than or equal to 3. Again, it's the same thing as before. Let me just correct this thing. So now you would write this thing 1 minus e raised to power of minus 4.5. This is 1 plus 4.5. Now let me use my calculator. So therefore this is 4.5 square over 2. 4.5 square. And this is divided by 2. That is 10.125. And this is 4.5 cube over 6. 4.5 cube. This is divided by 6. That is 15.1875. Now all these values are exact. Now let me add this thing. Plus 10.125 plus 4.5 plus 1, which is 5.5. This adds up to be 30.8125. Now let me multiply it with e raised to power of negative 4.5, and then it will be subtracted from 1. So now let me just shift this thing even down. And I'm just showing you the whole working. So now let me just write e raised to power of negative 4.5. So now this comes out to be the small value into 30.8125. That is 342295. 1 minus 0.342296. Now when we do the subtraction, this comes out to be 0.6577, so 4 SF, and then the final answer 0.658. So now show all this if you want to gain full marks. So show all this if you are interested in full marks, if you are interested in A stars in A, because you don't want to lose out on silly mistakes. So that is very necessary, no compromise on this. Now let's talk about the justification. That's done. Now part B. So still it's the same question and something very common sense, but it applies to everything. That is this first thing. This applies to part A. Of course, it applies to part 1. It applies to part 2. And it applies to part B. It's the same question that's going on. So now it says on average, the number of copies. That was about those errors. And now this is about copies of the magazine sold per month is 123.4. It still is following Poisson distribution. State one condition for X to have a Poisson distribution. We have to write in the context of this question, that is the magazine sold per month is occurring at a constant rate. It's sold singly. It's sold randomly. It's sold independent of one another. So make sure that you write in the context of the question. That is very necessary. Now it says you are given that X is a Poisson distribution. Use an appropriate approximating distribution. Again, it means approximation. Find the probability that in a randomly chosen month, more than 130 copies of the magazine are sold. So this is about a month. So therefore, lambda remains the same. Now you have to do the justification. What is the justification? Since lambda is greater than 15, X follows a normal distribution, lambda and lambda. Because we know that in a normal in Poisson distribution, expectation of X is lambda, so is variance of X. That is a rule. Now over here, let me show you the continuity correction. So show everything. Do not take any risk. So over here, this is 130. The upper class boundary is 130.5. The lower class boundary is 129.5. Let me draw two lines over here. The first line is a blue line like this. The second line is a red line like this. Now this line is starting from 129.5. This is 130.5. And this is not inclusive. So since this is not inclusive, therefore I have chosen the blue line, which is greater than 130.5. And then it's back to the basic, standardize, get the z value. This is the second rule. z greater than a particular value, 1 minus z of that value. Go to the table, 0.639. Let me show you this. So I think I have a normal distribution table, 0.639. So over here, this is 0.6 and then a 3, and then in the same direction a 9, that is 29, 7357. Let me write 7357, and this is 29 added without the decimals. So this is 7357 plus 29, that comes out to be 7386. This is 7386. Now put the decimal. So this is 7386. So this is 1 minus 0.7386, subtract 1. So therefore 2614. So this is 0.2614. This is 4 SF, and then round it off to 3 SF. That's how this thing is done. Okay, so I'm showing you every single step that is necessary. Now question number 5, a nice question, linear combination. It says the masses in kilogram. This is the mass. Okay, so the masses in kilogram of large and small bags have this distribution. So large is in red color, that follows this distribution, and the small is in blue color, that follows this distribution. Find the probability L is greater than S plus 0.5. So in other words, we have this thing which is L minus S is greater than 0.5. So now L minus S follows a normal distribution. The mean is subtracted, but the variance is added. So mean is subtracted, you get this. Variance is added, you get this. And then they are asking, find the probability L minus S is greater than 0.5. Z is greater than 0.5 minus this mean divided by square root of variance. We get a negative value. Z greater than a negative value is Z lesser than a positive value. That is direct reading. So of course, you know that you have to go to the Z table and then read off the value. Now this 5 mark, that was definitely worth it. Nothing difficult. They ask these questions a lot. The price of tomatoes is 4.30 per kg. So irrespective of whether it's in a large bag or in a small bag, so you have to take this amount, $4.30 per kg, and multiply with kg so that you are left with dollars. So now it says we are taking one bag of each. Find the probability. Total price is less than $16. So T is L plus S. So now over here, what have we done? We have taken the mean of large, we have taken the variance of large, we have taken the mean of small, the variance of small, and in both cases, technically, we are adding it up. So this is adding it up, adding it up. So therefore, we are getting this and we are getting this. This is for T. So this is T is the total weight. Okay, and have they used the word weight? Masses. So weight, and they are just not confusing with the physics. So this is the total mass of large and small bag, one of each. So now we have a new variable, that is C. So now we would say that C is 4.3 times T. So expectation of C, expectation of 4.3 T, 4.3 comes out and multiplies with this value, 3.61. This is what you're getting. Similarly, variance of C, that is variance of 4.3T, but the rule of variance, multiple, this is squaring. So now you are getting this value based upon this. And then C now follows a normal distribution, such comma such. We want it to be lesser than 16. So Z is lesser than 16 minus this divided by square root. Don't forget the square root. Z is lesser than this value. That is also direct reading. Give the answer correct to 3SF. Question number 6. Now they come up with all these creative ideas, and we have seen questions like this before, in which a straight line diagram is drawn. That is the y-intercept. The gradient is change in y over change in x. It's negative, of course. Why? Because the line is coming down. So first of all, I found the equation of the line. I kept it on the sidelines. Find an expression for b in terms of a. So the area of this triangle, half into base into height, equals to 1. Area represents probability. So B is 2 over A, that's 2 marks. Now this is 5 mark. First of all, we will use the formula for expectation, that is x into this line minus a over bx plus a. So when I multiply it out, let's focus on the variables. So this x gets multiplied with this x, it multiplies with a, so that is x square, that is x. You integrate it, you get x cube over 3, you get x square over 2. So now look over here, this b, this 2, 3, that goes on the outside, this 2, that goes on the outside. A was still there at the top with a negative sign, and a was still there at the top. So now when we integrate it and we plug in the limits, no need of showing 0. If you want to show 0, that is 0 and 0. Let me just show it over here. So now this is like this, and this is 0 plus 0. Nothing is happening over here. So now look at the working. This is b cube over b, that is b square, minus 1/3 ab square, and this is, there is no cancellation. So I've taken ab square common out, half minus 1/3, that's 1 over 6 ab square. Now expectation of x is 4 over 9. So half ab square is 4 over 9, but remember what is b equals to. So this thing over here, b equals to 2 over a. b equals to 2 over a. So substitute it in place of b, that is 2 over a whole square. That is 4 over a square. And this cancellation, and we find value of a as 3 over 2. So the value of a is coming out to be 3 over 2. That's right over here. So let me also evaluate b. They were not asking for b, but definitely we need it. b is 2 over a. That is 2 divided by 3 over 2. That becomes 4 over 3. So that's another value. So a is 3 over 2 and b is 4 over 3. So now this equation we need for, I'm working for this equation. So now for the equation y is equals to mx plus c, this was the gradient minus a over b, that comes out to be minus 9 over 8. So your fx is basically minus a over x plus a, minus a over bx plus a. Let me correct it, a over bx plus a. Therefore this is negative 9 over 8x plus a is 3 over 2. That is what is written over here, minus a over b, this is a, and this is the variable x. Now they are saying find the value of k such that probability x less than k is this much. So now we already know what is a, we already know what is b, we have the equation of a line. Now it's a normal question. So first substitute and then proceed. Minus 9 over 8x, that becomes x square over 2, 3 over 2 becomes 3 over 2x. This 2 and 8 multiplies, this is all basic maths, the 0 and the 0 is shown. Let me also emphasize a bit, that's the upper limit, that goes over here. This is the lower limit, that goes over here. Now once this is simplified, let's equate it to 3/4. So now I have multiplied throughout by 16, then I divided by negative 3. I get this particular equation. I do the middle term factorization. I get two values, k is 3 over 2, k is 2/3. Now which is the correct one? Again go to the graph. The limits are 0 and b. What is the value of b? The value of b is 4 over 3. So this is out of the range. This is out of the range. So that is why we reject it. This is within the range. We accept it, and k is 2/3. And I think that completes the paper. This is October, November 2025, variant 65. That is a nice one. And this is from the year 2025, and this is an S2 paper. So now in some papers you have seen they have 6 questions, in some you have seen 8 questions. So both possibilities are there. So don't count the number of questions, count the number of marks, and show all the working to make your mark and your working worthwhile and your efforts worthwhile. Take care, everyone.